Hi everyone, today we are going to present our project, which is a cloud-based fraud detection system. Our team members are Mi Yufan, Chen Yangli, and Weichen Wang. In this project, we combine cloud computing and machine learning to address real-world financial fraud detection problems. Next, we will walk you through our system step by step. Here is the outline of our presentation. First, we will introduce the project background and objectives to explain why this system is needed. Then we will go over the technologies we used and the AWS real-time fraud detection architecture. After that, we will present our data analysis and visualization results. We will also cover system monitoring and alert maintenance. Finally, we will discuss the future improvements and give a brief conclusion. Let's start with the project background. Financial fraud is a major challenge, especially for backgrounds and online payment systems. Traditional rule-based systems are often slow and limited, and they cannot easily adapt to new fraud patterns. To address this, we use machine learning to detect hidden and complex fraud behaviors. By combining this with cloud computing, we can build a real-time and scalable fraud detection system. Now let's talk about the objectives of our project. Our main goal is to build a cloud-based fraud detection system. We aim to automatically detect suspicious transactions without relying on manual rules. We use machine learning models to analyze transaction data and improve detection accuracy. We also build a real-time streaming pipeline to process continuous data. All results are stored and analyzed in cloud. Finally, we visualize fraud patterns using dashboards for better insights. This slide shows the technologies we used for our environment. We use Ubuntu Linux 24.04 and Python 3.12 in our setup. Ubuntu acts as a survivor that simulates transaction data and sends real-time data streams to Amazon Kinesis. For AWS survivors, we use several key components. AWS 3 is used for storing data and prediction results. Amazon Kinesis is used to receive real-time streaming data from our Ubuntu server. Amazon Lambda processes the data and performs real-time predictions. Amazon SageMaker is used to train and deploy machine learning models. Amazon Athena is used for data analysis. Amazon QuickSight is used to build dashboards for visualization. Finally, Amazon CloudWatch and SNS are used for monitoring and alerts. Together, these components form a complex real-time fraud detection systems.
And now I'm going to talk about Lambda interface insurance process. So next I'll walk you through the core execution logic of this system. The heart of our system is AWS and Lambda. When Amazon Kinesis receives real-time transaction stream data, Lambda is automatically triggered and executes three key steps. First one, data preprocessing, converting the raw JSON format into feature vectors that the model can read, and handling missing messages. Second, real-time inference. It then calls the Amazon SageMaker endpoint to perform classification using our pre-trained S3 Boost model and ensure extremely low latency. Last but not least, resource storage. Finally, the predicted labels and risk scores are stored back in Amazon S3. providing a data source for subsequent analysis and visualization. So, before moving on to the automatic pipeline, we must first understand this machine learning model that underpins the inference core. We selected XGBoost as the algorithm for fault detection. So, why do we choose XGBoost? Our decision was primarily based on the following four considerations. First, high accuracy and performance. It excels at handling classification problems and is well suited for distinguishing between legitimate transactions and fraudulent transactions. And second, handling large-scale data. It can efficiently process the massive datasets found in the financial area. And second, track record in the financial industry is currently one of the most widely used models in the field of financial fraud detection. Okay, next page. So, AWS LabLab is the core of our real-time processing layer, offering the advantages of low latency and high scalability. Our number function workflow consists of the following four key steps. Data ingestion. Continuously consume transaction even from Kinesis to ensure high throughput data ingestion. Reprocessing, clean and normalize raw JSON data, then convert it into the format required by the model. Model invocation, sending requests to the deployed SageMaker endpoint to achieve millisecond leaf file detection. Last but not least, and resource storage. Finally, storing in the prediction resource, including levels and resource in Amazon S3 for subsequent use in Athena queries and QuickSight. Okay, and after the data is stored in S3, we use Amazon Athena to perform serverless SQL queries and extract key sets. The first one is chain analysis. We observe quite and cyclical spikes in fraudulent activity, suggesting the possibility of quadratic cyber attacks. Second, category vulnerabilities. Specific transaction types exhibiting extremely high fraud rates, helping us identify vulnerabilities in the system that are more susceptible to attacks. Third, geolocation. We have pinpointed high-risk regions, enabling banks to implement more precise risk control strategy for specific areas. And next page. To turn data into actionable insights, we built an Amazon QuickSight dashboard. And this dashboard provides multiple dimensional monitoring, including real-time trends in geographic distribution, which monitor daily and hourly risk fluctuations. And the second one is model confidence assessment. Using a prediction score distribution chart, we can assess the model's confidence in its judgment results. And the next one is high-risk list. We have completed a list of high-risk transaction details requiring further model manual investigation, directly supporting business decision making. Okay, so to ensure the system operates stably, we have set up 5 key safeguards in Amazon CloudWatch. And the first one is processing delay hours, monitoring data backlog in Kinesis, and allow its trigger if the delay exceeds 60 seconds. And the second one is execution error alert, monitor lambda for any execution failures. The third one is model performance alert. We monitor interface latency, which must be lower to 3000 ms, and like 500 of service areas to ensure uninterrupted SageMaker inference. And business anomaly alert. If the fault prediction rate exceeds 20%, the system identifies it is an abnormal attack and immediately sends alerts via SMS. And that is the end of my part. Next, I will hand on my time to my next team members.
Hello everyone, my name is Chen Yang, and in this slide we will talk about the benefits of our system. First, our system can detect fraud in real time. This helps reduce financial loss and allows faster response. Second, the system is scalable. It can automatically handle more data when transaction volume increases. Third, machine learning is fully automated. We use SageMaker to make prediction without manual work. Also, we use Athena for data analysis. It allows us to query large data directly from S3 without setting up a database. QuickSight provides clear dashboards. This helps users understand fraud patterns easily. Finally, CloudWatch helps monitor the system. It can send alerts before problems happen. Okay, next we look at future improvements. First, we can use large and real-world data sets. This will make the model more accurate. Second, we can improve the machine learning model. For example, we can try deep learning models. Third, we can deploy this system in real production environments. This means connecting it to real banking system. We can also add more advanced monitoring tools. This will improve system stability and performance. Overall, there is a lot of room to make this system more powerful. In conclusion, we built a cloud-based fraud detection system using AWS. This system combines machine learning, cloud computing, and real-time data streaming. It can automatically detect fraud transaction, scale with data volume, and monitor the system real-time. This project shows how AWS services can work together to build an intelligent system. It also demonstrates that cloud computing and AI can improve financial security and reduce fraud risks. Okay, so thank you for listening. We appreciate your time and we are happy to answer any question.
We upload the real CSV file to this, and then we use SageMaker to training and deploy our model. After deploy, we can use the Ubuntu Linux to start our real-time streaming. Now we can monitor in the Kinesis. There are some streaming and also Lambda and CloudWatch. The results will be stored in real time. Now we can start to query. We can create a database, create a table, and refresh table, and preview. And do some queries. Then we use the quick sets to visualize our data. And we also create 5 alarms in CloudWatch. That's all our project demos.